Okay, we are starting a new unit in physics this week on conservation of energy and momentum. And this is the first video for that unit. This lecture is on energy types, transfers, and transformations. And the essential question we're trying to answer here is, what is energy and how does it move around in a system? So when we talk about the variable energy in this class now, we are going to use the symbol of a large E to represent that variable. The units of energy are joules, which are represented with a large J. A joule is actually a combination of a bunch of other units we've talked about previously, which we can get into later. So what is energy? It's essentially the potential to make something useful happen, or the ability to do work. You probably remember from previous science classes that there are two main categories of types of energy, kinetic and potential. And we are going to go into many different types of kinetic and potential energies in this class. So hopefully you'll understand both of those categories more in depth by the end of this. So let's take a look at kinetic energy first. Objects or pieces of objects have kinetic energy if they or parts of them are moving. So kinetic energy is energy associated with motion. We're going to go through some different types of kinetic energy and show you which things have small amounts of this energy and which things have large amounts. So EM stands for the energy of motion. An example of something with a small EM would be a turtle, and a large EM would be a race car. One has a lot more motion than the other. Rotational energy is another kind of kinetic energy. A bike tire has rotational energy as it spins around the axle, and a planet has a large amount of rotational energy as it goes around the sun. Thermal energy is another kind of kinetic energy, and this is because what actually makes things warm is the motion of the particles that they are composed of. So the faster molecules move, the more thermal energy something has. So ice has a low amount of thermal energy, whereas hot lava, molten rock, has a high amount. Light is a form of energy. A flashlight has a small amount, whereas a laser has a large amount. Wave energy can be present in lots of things, from the waves created by an earthquake or the ocean or sound. So a whisper would have a small amount of wave energy, and a tsunami a large amount. Our second category of energy is potential energy. So objects have potential energy if their shape or position enables them to store energy up. So this doesn't have anything to do with motion. The type of potential energy you're probably most familiar with is EG, or gravitational energy. If an object's position is above the surface of the Earth, it has gravitational energy. This would be very small for, say, a piece of snow, but much larger for something that has larger mass, like the space shuttle. Another type of potential energy is electrical energy, or EE. An electron would have a very small amount of electrical energy. We haven't talked about parts of an atom yet, but an electron is a tiny part of an atom, and the amount of electrical energy you have is dependent on the relative positions of these little things, electrons and protons, with respect to each other. So a high voltage power line would have a large amount of electrical energy. ES is spring or elastic energy. So you can store energy in a rubber band or in a spring by compressing it or extend, and as it extends, you're releasing some of that energy. A rubber band has a small amount compared to something like car shocks. Chemical energy you are also really familiar with because you need to consume food as a form of chemical energy to power your body every day. So a peanut would have a small amount of chemical energy in it. A battery, chemical battery, would have a lot more stored up. The last kind of potential energy we're going to talk about is EN, or nuclear energy. And this has to do with energy stored in the nucleus of an atom. So bananas actually have a bit more nuclear energy than other foods because of the potassium inside them. But all things have some nuclear energy because all atoms have a nucleus. Nuclear reactors have a great deal amount more nuclear energy than other things. So one of the big ideas that we covered in our last unit that we're going to continue talking about in this unit is the idea of conservation. And when we're talking about a closed system, energy is conserved. This means that energy cannot be created or destroyed. But what it can do is it can transform from one type of energy to another type. So the chemical energy that I put into my body in the form of food gets transformed into motion energy and heat energy as I move around the classroom. So that's transformation. It's not destroyed, it just changes from one type to another. Energy can also be transferred from one object to another. So the kinetic energy of your foot as you swing it through the air to kick a soccer ball, the kinetic energy from your foot is transferred to the ball, and then the ball has kinetic energy. So if you look at our closed system over here on the right, you can have lots of different kinds of energy, but we can transform from one type to another and transfer from one object to another, but the total energy in a system, the sum of all those energies, will always be a constant. So energy can be transformed and it can be transferred from one object to another. We're first going to talk about energy transformation. So work is a physics word that means that energy is being transformed from one type to another. So let's use the example of this skydiver duo. The skydiver has some mass and is located at a position above the earth, and as they fall, their gravitational energy is being transformed into energy of motion. Another example could be this girl who's moving around in this giant blow-up ball, looks like in a pool. As she moves, she is transforming the chemical energy in her body into rotational energy as that ball rotates and moves forward. So in both of these cases, no energy is being lost. It's just transforming from one kind of energy to another kind of energy. Sometimes we think that energy is being lost when it really isn't, and that's because some other types of energy are being generated that we think of as waste energy as well. So energy transfer is another way that energy can move around in a system. Energy transfer is when energy is moving from one object to another object. So all energy can be traced back to the Big Bang. So if you have a light on in your room, for example, we can trace that energy that's coming out of your light all the way back to the Big Bang. So if we think back, the motion energy from that Big Bang ended up getting transferred into gravitational energy as in little forms of space dust, which started to clump together. And as you had a lot of space dust start to clump together into bigger and bigger and bigger chunks, when you had a large enough mass, nuclear energy started up with the suns and stars. Those nuclear reactions then created light energy as sunlight, which transferred down towards our Earth, turning into thermal energy as it heats up our planet. That thermal energy was then transferred into gravitational energy as little bits of evaporated water in the atmosphere are high above the Earth, and then they rain down into the Columbia River. As the water in the Columbia River flows, it turns giant turbines, moving turbines, creating or transferring to electrical energy, and that electricity goes all the way through the power lines to your wall socket, which is finally transferred into light energy in your bulb. And again, lots of energy turns into waste energy along the way as energy is transferred, but it is not destroyed. It still stays within the system. So to summarize, what is energy? Look back through your notes and see if you can answer this question, and see if you can also answer, how does it move around in a system? This is a good time now to fill out the graphic organizer at the in your notes section, and work on the extension questions to help be prepared for class.